A few things to note about our mass distribution data, collected using an e-cigarette battery, a vision spinner, at its lowest setting and its highest setting, compared to cigarette smoke. We see that the loss in count concentration as we went from low power to high power is far outweighed by what seemed like a small gain in count concentration at approximately 1 micron. When we look at the mass distribution, remembering that mass is a function of volume multiplied by density, and volume is 4/3 pi r cubed, an increase from 100 nanometers to 1000 nanometers is a tenfold increase. This results in a 1000-fold increase in mass. Though we lost a lot of particles in the nano size, the 100 micron region, and we only seem to gain a few particles in the 1000 region, we should note that this peak is about even on the left-hand side, but it is right shifted. And that small difference, because this 1 micron particle is 1,000 times more massive than a 100 micron particle, this small increase in count is actually a very large increase in mass. We also would note that the cigarette smoke, which has a mode around 300 nanometers and 800 to 850 nanometers, actually has more mass at the approximately 1000 micron size, 1000 nanometer size range than the low power e-cigarette, but not near as much mass as the high powered e-cigarette setting. Again, we should point out that there is a lot of mass found in these relatively few particles at 5 microns and up, but we should note that 10 micron to 20 micron particles deposit in the upper respiratory tract. In Figure 9, we can see the mass distribution data has a very clear trend that there is very insignificant amount of mass accumulated in the nano-sized region, but a very dominant peak emerging at approximately 1 micron. Again, this peak is right shifting. As it's growing, it is becoming larger on the higher diameter side. This results in it becoming more and more massive. We saw a clear trend that we had a loss in particle count concentration as vaping power was increased, and we had a clear trend of particle count concentration increase as vaping power was increased at the 1 micron. We can see that the mass that is associated with this increase in particle count concentration is quite significant. Again, we see a high abundance of particle mass at 10,000 to 20,000 nanometers, or 10 to 20 microns. The rapid increase in particle count concentration and particle mass at approximately 1 micron is likely due to kinematic coagulation. This is because as we generate high concentrations of nano-sized aerosols, they bump into each other, they coalesce together, and they become a slightly larger particle. Once we start to form particles that are roughly 800 to 1,000 nanometers, these particles don't bounce around very fast, and they act as sinks or scavengers for the nano-sized particles. And so these small particles, this small abundance of particles, can absorb millions, literally millions, of these nano-sized particles and hardly shift in mass, and maybe increase from 800 to 900, 900 to 1,000 nanometers. This is actually exactly why we see our median and our mode right shifting as we increase our vaping power. We are forming a tremendous concentration of particles in the nano-sized region, which are then being rapidly scavenged by our particles that are roughly 1 micron.